Got it. And start the recording to the cloud.
All right. Okay, got it. Welcome, everyone. Welcome back to the next Water, Wetlands, and Watershed Seminar. So this week, it's my pleasure to introduce our speaker. This is Dr. Johanna Engström. She's a physical geographer that she specializes in hydrology, climatology, GIS, and renewable energy. She's particularly interested in large-scale atmospheric drivers of climate variability. We'll see that today, with applications for water resource management and renewable energies. So I want you to think about, like, what the heck does hydroclimate have to do with renewable energy? Well, yeah, you're the professor. So for the students, let's think about that. Keep it in your mind. Since joining UF, she has developed a course, The Future of Energy, and also teaches a physical geography course. Originally from Sweden, Dr. Engström completed her BS and MS in physical geography and ecosystems analysis at Lund University, then worked as a consultant in the European wind power industry. After working a few years at the University of Alabama at Embry-Riddle Aeronautical University here in Florida, she rejoined the UF Geography Department as an assistant professor in 2021. So the floor is yours. I will reshare the screen. And like this. And you should be good for both.
Thank you.
All right.
Perfect. So hello, everyone. Thanks for coming. So as David mentioned here, my research has focused a lot on large-scale climate variability, hydroclimatology, and renewable energy. As I come from that background, I'm working as a renewable energy consultant. However, today I'm going to speak a bit about the hydroclimatology of southeastern US and also the whole US, looking at droughts, actually, and drought vulnerability. So we start with the hydroclimate of the southeast US, look a bit at future outlooks of drought here, using some satellite data to look at long-term changes in water resources. And then I'll talk about drought vulnerability in the US. And one of the conclusions is that California is not very vulnerable to drought, and I'll explain that later. And if you like shrimp, farmed shrimp, it might not be coming from where you expect this. Okay, so let's start with the southeast US. Many of you can do a PhD here at UF, and probably related to water somehow since you're here. You might be familiar with hydrology, hydroclimatology in this region. But the water in this region is managed to meet a lot of different needs, both recreational needs, which we sometimes might think is a secondary need, but there's a lot of money in the water resources, right? Also drinking water and hydropower, not directly in Florida, but 3 out of the country's top 10 hydropower producing states in southeastern United States. It's Alabama, Tennessee, North Carolina. Who would have thought, right? So there are a lot of conflicts over water in this region, sometimes referred to as the water wars. It started with Georgia and Alabama, and has just grown since. Whenever there's a drought, it seems like this flares up again. We see some headlines about that down there. Depending on when drought happens in this region, it has different consequences. In the warm season, it affects the agriculture, and in the cool season, it affects the recharge of storages, in both natural water storages, but also, for example, hydropower storages, like this one right here. This is a picture from Georgia. So first I wanted to talk about 2 papers a little while ago on drought in the southeast. So this region has had a number of recurring droughts. As you see, a number of years there, 86 to 88, 98 to 2002. Most recent one, 2016 to 2017. And that is when I was just finishing on my PhD. My significant other dragged us to Alabama, and there was all over the news that it was such a bad drought in Alabama, and there were new records broken on the most consecutive days without rain in that region. And in the morning when we got out of the house, we would smell the smoke in the air. We didn't have any fires around where we were, but you could smell it because there were so many wildfires around. Huge agricultural losses. People had to get rid of their livestock because they didn't have enough feed for them and so on. In the spring of that year, there was a state of emergency in Florida due to the droughts. And here's just a picture of the wildfires. This is in Gatlinburg, Tennessee, in December 2016. Side note, my 30th birthday was in the end of November. We're like, what should we do? Let's go to Gatlinburg. It's supposed to be a cool place. So there were actually wildfires already in November. So we went to Las Vegas instead. So that was a pretty good birthday after all, I have to say. But this is the drought monitor there from the end of November. And let me just zoom in on that a little bit. It's the same one, just enlarged. And you see California is right over there. The drought there was all over the news for a long time, all over the international news too, right? It was very severe. However, I will argue, if you look at this globe over here, oh, I got a nice stick here, right? If you look at the size of this exceptional drought right here, I would argue it's at least the same size as the one in California. And this brighter red is larger than the one in California. So a very severe situation here, although it didn't gain as much attention. But that then motivated this study that we did. So that was an extreme drought that happened then. So the objective was then to investigate the severity of future dry periods in the southeast US. And using the same approach, the number of consecutive dry days. There are different types of droughts, but we thought we use this consecutive dry days because that is what made news that year. So we looked at the drought with 20-year return period, divided the data into the cold and warm season, because we realized the impact of the drought is different depending on when it happened. We then used 32 downscale CMS5 models, 2 different RCP scenarios, so future climate scenarios, and 2 time periods. With the motivation that sometimes when you look at data for the future, it's like, yeah, in the next 100 years, this will happen. And it becomes so, I think somehow, it's like sometimes in 100 years, this might happen. So we're like, okay, let's do 2 time periods. One is the near future, one is the far future, better into the future, just to kind of see if we can see changes between those 2 time periods and what's the most urgent changes we can expect. So first of all, just looking at how long is the 20-year drought in the southeast? And we have a number of climate regions here. So this is just looking at the observed daily precipitation. So meteorological droughts with a 20-year return period, not very long in the warm season. We just look here at the gates, so that would be 46 to 50 days without precip. Well, if that's in the summer, that's quite dry, right? In the winter, not a huge difference right here. But typically, it's, I don't know, it's like Gainesville is right
near the border of those two,
yeah, it's possibly slightly longer in the cold season. But you can definitely see this north to south gradient in the cold season, where the south can get a lot drier than the north, because the cold front bringing all that precip doesn't make it all the way down there very often.
And just some of the students may not understand a 20-year drought. How long is a 20-year drought? Some of them might say 20 years. So
Okay.
just to think about the,
Okay.
Yeah.
Thank you.
Yeah.
Yeah. So when we're looking at extreme events, say it's a flood or a drought or something, it doesn't happen every year, right? Some years it will be very bad droughts. And then looking at the stats of how often a drought happens, we can say, well, on average, a drought this bad would happen every 20 years. You can also say that can be a 100-year drought. So a drought that's so extreme, it's only 1% chance of it happening every year. And so you more often hear it in regards to flooding, like the 100-year flood elevation. So this is the 20-year drought. Good point.
Yeah, I think that helps.
20-year long drought.
Associating it with the floods, I think they're more familiar.
Yeah,
So
yeah, thank
great.
you for pointing that out. So first we thought, how well do the models actually replicate the historic data? So the historic droughts, I used a number of downscale models. I listed them all here. I'm not going to go through them. But we then looked at the historical data and the models and looked at how well the probability density function, how well the fit was, both the overall fit and then the tail fit. So above the 20th percentile, so where those extreme droughts are. And just to show you some of the output, the maps here furthest to the left are the same maps I showed you before. So the observed droughts, warm season and cool season. Then you see the output from the five best models, is the average of them. So we want them to look as similar as possible, right? And they're quite similar. Especially these two are very similar. These are the 5 worst models, and we can say that, yeah, they are different. Definitely different, especially in the warm season. So what we did was to move forward with 5 best models and let them inform what might happen in the future. These are those best 5 models, and they're different in the summer and in the cold season. So what I'm presenting then is the change in this 20-year term period, okay? So the relative change, will the dry periods get longer or shorter? These dry periods with a 20-year term period. And if we look at the near future over there, we kind of have a mixed bag of responses here for the RCP 4.5, which is the intermediate future scenario. Well, the most pronounced one would be the cool season, the most extreme case, where we get shorter. So it's blue, and it's shorter dry periods in Florida during the cool season, and actually longer dry periods in the continental portion of this region. And the same patterns really emerged in the far future, especially in the cold season for both scenarios, right? Where we get a shorter extreme drought in Florida or much of Florida, while it's tend to get drier in the more continental parts of this region. So all we can conclude is that the models perform better in the cold season, which isn't surprising really, because the frontal action that we have in the cold season in much of this region is a lot easier to forecast and predict versus the summer convection and hurricanes. That's just tough for any model to deal with. About 25% of the region is predicted to see 5 to 10 day reductions in the 20-year return, CDD, consecutive dry days, not cooling degree days, and warm season, and up to 20 days longer droughts than often on more continental locations in the cold season. And changes are present in both the RCPs and future time periods, but most pronounced in the later time period and the more extreme RCP. So staying in the southeast, I have done this study here using the gray satellites. Are you familiar with the gray satellites? No, they are a bit different than many other satellites. So I'm thinking, when I went to university and learned about satellites, you look at land cover and NDVI and land cover changes and things like that. However, these are really cool, these 2 satellites. They're called twin satellites. They fly together. They shoot beams towards each other. Picture Star Wars. Not quite. But anyhow, and they measure Earth's gravity. So if one of them fly over an area with increased gravity, it will get pulled a bit closer to the Earth, right? And then the signal that it's sending to its twin will notice that, okay, the other twin moved a bit. There's a change in gravity. So what's changing in gravity on Earth? Well, if you move masses around, for example, if you have a volcanic eruption, if you have an ice sheet that's melting, then there is less weight there. If you move a lot of water around, water is very heavy, it can change the gravity of the Earth, okay? So that's what these 2 satellites do. They measure gravitational changes And then they report that in liquid water equivalent, in centimeters of thickness of water changes on Earth. And these are collaboration between NASA and a number of German institutions, as well as the University of Texas. So what inspired me to do this research is actually a course I took at UF 5-10 years ago. So as professors, we got to remember, you never know what paper or what slide will inspire a student to just go off and do a study. And we're actually preparing a proposal related to this now too. So this paper just blew my mind, because this is for 2011, so it's a bit older, but it was a while ago already too. So it's called the 2011 La Nina, So Strong the Oceans Fell. So maybe you're familiar with ENSO, El Niño and La Nina, right? And we are familiar probably with that it's centered in the Pacific and affects the regions there, but also weather all around the globe. It brings droughts and heat waves and flooding and so on. However, what they did in this paper was to look just at where does the water go when this happens? Because the sea levels actually dropped 5 millimeters. We know they're slowly rising because of climate change, but between 2010 and 2011, the global sea levels actually dropped instead. So this paper then looked at, well, where did all that water go? 44% of it ended up right here. 39% ended up in Australia. Australia is the driest continent on Earth. So it just works as a sponge. When it starts raining there, it just sucks it up, right? So, and you see a few other regions got increased water content as well. So to me, that was just amazing. And that inspired this research. But I'm in the Southeast, so I just scaled it down a little bit. And I thought, well, let's see what's happening here in the Southeast. So here we have data from the Great Satellites, just showing water anomaly from 2002 to 2016. I ended there because one of the satellites failed. And now there are 2 new satellites up there. So we're working on merging the data sets to make longer time series. But anyhow, you can see a pretty clear seasonal signal here with a high on average in March, right? That's the blue March average here, so high, and then September is a bit low. And you can also see some of these droughts that I pointed out before. One of the very extreme droughts right here, 2006 to 2008, really stands out as being extremely low water anomaly in this region. And I just made a small visualization highlighting one of them. So here we're starting in October 2006. This is an anomaly, but if you look up here, it's not extreme for that time of the year, right? But as we move forward, first it gets wetter, right? With anomalies up here, and then the drought is creeping in from the south. And this is the driest observation in the whole record, where we have an anomaly of 127 cubic kilometers of water in this region. It's a very, very dry. Then looking at the long-term trend, we find a significant decrease of water right here between Alabama and Mississippi. There's also an increase over in Georgia and South Carolina. However, that's not statistically significant. Still interesting though, as we know that there is a net transfer of water over in this region from this watershed right here. However, the stats can't support that, unfortunately. So, but the rest of this study focus on that square right there. What is going on between Alabama and Mississippi? Because looking at the trend, this region lost almost 12 cubic kilometers of water during this time period. And if we look at well data in this region, which is not all that well monitored actually, but all these red dots here show a decrease in wells. The gray ones have no change, and then a couple of them have an increase. But you see there are a lot of red dots in this month. So where has the water disappeared from? This is the time series again of GIS data, the full GIS data, and then we have surface water and soil moisture in there too. So the difference there, whatever is between these two guys and here, would be groundwater, right? And you can see then at times of droughts, this gray region really grows a lot. First, it impacts the soil moisture, then the surface water, and then the groundwater. So we're like, okay, has the precip changed in this region? You know, maybe it's gotten drier. Actually not. It has, if you look at the long-term record going back all the way to the 50s, it has increased slightly in this region. If we look at different time periods, there is no significant decrease. Instead, there is a slight increase. So that cannot be the explanation. The reason we believe are these guys right here. Shrimp and catfish. This picture here, if you're familiar with satellite images, these are not fields, these are ponds. This is in central Alabama. Driving south from Tuscaloosa, Alabama, which if you haven't heard about it, don't worry. If you're into football, you might have heard about it. Otherwise, you probably never heard about it. When I heard we're moving there, I had to take the map out and be like, where are we going? Yeah. Anyhow, so this is like in central Alabama. There's no water anywhere to us. Well, there are some streams, but it's pretty far from the ocean. And there are all these ponds all over. So actually, in Mississippi and Alabama together produce 80 to 90% of the nation's catfish in ponds just like these ones. So very large ponds, and they extract groundwater for this aquaculture and also for irrigation. Because in Alabama, they have this riparian rights law. So you cannot touch any surface water unless your land is right by it. So if you're a farmer and you don't have any streams on your property, it's pretty complicated to irrigate your crops. You might get permission to build a well or drill a well. However, it's not very well controlled over in Alabama. So if you look at groundwater extraction changes from USGS, there is the overall decrease by 4% over this time period, more or less the time period we're interested in. However, agricultural groundwater increased by 29%, and a lot of these ponds have been constructed in the last 10, 20 years. And as you can imagine, this causes extensive evaporation. So they pump up groundwater, put it at the surface, put in shrimp and catfish, and then a lot of this is just evaporating. There's a net loss of water right there. So, green prairie shrimps from Alabama. They actually have salt water right there. So talking about making lemonade out of your lemons. They don't have fresh water in this region. The groundwater is salty. That's why they can grow shrimp in central Alabama. There's also some oil and gas extraction in this region. However, that's decreasing and not really significant. Okay, so the next thing I wanted to talk about here is drought vulnerability in the US. Also, so much of my life in Alabama has inspired this research. But I did a postdoc part of time I was there. We worked a lot at these grant applications. And we always pushed it like Alabama is so vulnerable to drought, the Southeast is so vulnerable to drought. And I thought, is it really? What is drought vulnerability? And are we more vulnerable than other places? So let's look into that. So if we look at this data from NOAA, drought is listed as one of the most expensive types of disasters and natural hazards in the US. So huge costs. However, it's not as visually obvious of a hazard as a tornado or a hurricane, or something like that, right? But it does cost a lot of money. So this is our framework, and I'm not going to go through all of it. But I wanted to tell you a bit about our indicators. So what makes a place vulnerable to drought? In the US, as a country that's quite vulnerable, we're not talking some developing country here where people will like start starving and have to flee or give up their life because of a drought. However, it's still an issue in the US. So what we're looking at here was an indication of vulnerability would be, for example, how often is there a drought in a state? How many people live there? Like if a drought happens where nobody lives, does it really matter, right? Also, considering ecosystems here, are there any protected waters in that region? We're also looking at sensitivity factors such as how much agricultural is there, how much cattle need a lot of water, right? Hydropower, okay? So going into, if it's in a state that produces very much hydropower, maybe supporting both themselves and surrounding states with electricity, if they have a drought, that's an issue. And we also put recreational lakes in there and renewable water resource. So how much water this state has coming through it, basically. And then adaptive measures such as, do they have a drought plan, which most states have? Some actually don't. How much of their farmland is irrigated? And then their financial muscles, basically the GDP per capita. So looking at these three groups of indicators, then this is what we get over here. And let me just start here from so this is exposure, right? How often is there a drought? How many people? How much protected waters is there? And we have then divided this into quantiles. So very high is actually up here, which a lot of people find surprising, but a lot of people live up there, right? So a lot of people will be impacted if there is a drought. And New York State has a lot of protected waters. Okay, so there is the highest exposure scores up there. Sensitivity, this region when there's a lot of farmland is very sensitive, really stands out. And then adaptive capacity is more of a mosaic, right? It really varies. California stands out as being very well adapted to drought, which is not surprising at all. Putting it all together, this is our relative vulnerability of the US states. The most vulnerable is Oklahoma, Iowa, and Montana. And the least vulnerable, California, Delaware, Connecticut, and Massachusetts. However, we also realized that now we just took all those indicators, we averaged them per category, and then we averaged them to 3 categories. And every category had different numbers of indicators. So we then did a probabilistic approach, letting the weight of these indicators vary 1,000 times. And we got these distributions then to see how sure are we of the score that this state got. And here's just the overview of the results. So for some of these states, they could have been in quite a few of the categories. It's very sensitive to the weights. However, we would conclude that the ones that are the most vulnerable, it's pretty clear that they should be in their category. So I said Montana, Iowa, and Oklahoma are the most vulnerable. And yeah, they're in the top 4. We get South Dakota in there too, if we let the weights vary. But definitely they're where they should be. Same thing if we look at the least vulnerable states. Delaware, Massachusetts, Connecticut, and California, they're in the top 5. We get Maryland in there too. If we let and the weights vary. So in conclusion, about 33% of the US is classified as having high or very high drought vulnerability. You have the most vulnerable states right there, and the most resilient ones, Delaware, Massachusetts, Connecticut, and California. And with that, I'll say thank you, and we welcome any questions you might have.
All right, thank you.
I'm going to switch the camera to the room camera. We can actually see everybody. Let's try that. Right. So, oh, look, you're there. You're live. Okay. So we'll take any questions from the room. I'll check YouTube, but you guys go ahead and start. Dr. Brown.
The vulnerability scale, you had three different things there. Are they weighted equally?
Yes, they are.
And you can reshare if you want to. Yeah,
Sorry,
that's okay.
did I reshare it with everyone or just here on the screen?
Sure.
Yes, they are. You mean these ones here? They're
Yeah,
close,
those three.
Yeah, we weighted them equally. Yes.
What do you think about changing the weight?
You know, that is kind of what we did here, but what we did was to change the weights of each one of these.
Okay.
Right, because some of them, like sensitivity here, had like 5 different indicators, and this one only has 3. We're
Right.
like, yeah, let's change the weights of those. So we didn't change the relative weights of the categories, but on the indicators. Do you think it will make a difference if we do it on the categories?
Well, I was looking at California winding up being the least vulnerable.
Mhm.
And, you hear about
Yeah,
California constantly, and there are water wars, and they're moving water from one end of the state to the other.
Yeah, so the answer there is their adaptive capacity. I
Yeah.
believe they are the only ones in the very high
Right.
there.
So
Because
that
they're
is-
so used to drought, they have all the drought plans, they have the financial muscles, they know how to manage their water. So a drought hitting California is better managed than a drought hitting Alabama, right? That the impact on Alabama would be a lot worse if a drought of even a lesser magnitude would hit Alabama or Mississippi than it hits California.
So the economic costs, are they in there? They're in there in
And we don't look at the economic cost of it, but that is a good point, because if we're looking at the national scale,
yeah.
the impact is California of the drought is a lot worse. And we actually have an incentive proposal about that. So
Good.
it's encouraging that people ask that, and it feels like it's not just us who think that's motivating to look into. Because yeah, the national impact will probably be bigger, but the state itself,
Yeah.
the impact on the state would not be as bad.
Is there anything that weights the duration of the drought as well? Because something like agriculture, if you have, a short term, you might wipe out one crop year, but if you have a really extended, it might have a different implication. So is
Yeah.
there any duration of drought that you identified here as the response?
No, we didn't. Actually, we didn't consider severity of drought, and actually not timing of drought either. We're just basically say it's a drought bad enough to actually impact the cattle and agriculture, but we didn't specify how bad it has to be, because that could be relative by state too, both what kind of drought, what kind of crops they have, and how resilient they are, whether they can irrigate or not. What was surprising to me was that a lot of these states that came out as the most vulnerable are very reliant on agriculture. For example, Iowa, and there's so little of their farmland that's irrigated. Because I guess traditionally they didn't need it,
But
right?
one good
But if the
drought-
drought hits, they're very vulnerable.
One good drought's gonna cause a lot of irrigation problems. So that's what happened in the southeast, is that some of the droughts identified created a lot more irrigation
Mhm,
to try to mitigate for the drought, just like California's been doing for a really long time.
mhm,
So,
yeah,
Right, so the vulnerability is not just like hydroclimatically dynamic, right, or varying, but also like as all of these
human response.
indicators, right, the human responses change,
mhm,
they all become more like California.
yeah. Did you have a question?
Yeah, I was wondering, what do you think is the most effective opportunity to decrease vulnerability to drought?
And I'll just repeat it in case those online, so what is the most effective approach to decreasing drought vulnerability?
That's a very good question. The easy fix would be drought plan. States don't have that. Well, 3 states don't have one, and then there was, would that be maybe 4 or 5 that have one that was more than 20 years old, so maybe updating that. I would also say maybe this is very much, sensitivity is very much linked to the state's economy, activity in that state. And maybe some states are not fit for agriculture. Maybe they're not fit for having a lot of cattle, if they don't have enough water resource themselves to support that. And maybe they did 100 years ago, but maybe they don't anymore. So it's in these two, you can then adapt your state's economy, right? And also do measures, so you prepare when the drought will come, because it will happen at some point, more frequently in some places than others.
Yeah, I have a good question. I was thinking about the wildfire. So do you think the wildfire could be the one of indicator in here? Then probably the result will change, right? But in here, I don't see any wildfire here, right?
No, I don't include wildfire. That's a fair question, especially if we're talking about California and the ones. However, a drought can be very bad in a region that doesn't have wildfires, right? The wildfire is a result of drought. It's always heat wave, and then it's like, well, should we also look at heat waves, right? And so it becomes very big. These we would say are secondary things. First, a drought happened, and then we have other things happening as a consequence of the drought. So we do not look at the wildfires in this study.
For the GRACE study, I noticed you have the Southeast and then you don't have Florida.
Yeah.
And so of course, that's very disappointing. And it's probably a very straightforward reason why, but can you tell us why you leave Florida out?
It's actually because when I started this has been my study region for most of my PhD. Actually, because I focused on hydropower and we didn't have much of that in Florida. Right, so I had all the data from this region, which is a very poor argument. However,
It was on your hard drive.
I'm sure about what the data would say about Florida. You know, it's about here's the springs, and so much groundwater, so much things going on underground. So I was like, I do a less complicated region first. And then I want to look at Florida too.
Is that the size of a GRACE pixel?
No, that's a couple of things.
Yeah.
Yeah.
Something like 250 kilometers. It's large. They're pretty large.
They're pretty
right?
large, so I used the downscale version of it. Let me see if I go back. Yeah, here you
Something
can
like
see.
that. Yeah. Okay.
Yeah.
So there's a couple of pixels across the state.
Yeah.
Okay.
Yeah, definitely.
There's just been some very interesting sort of water resource changes over some of them that predate the availability of GRACE satellite,
Mhm.
but so, and probably someone looked at GRACE on the peninsula of Florida, but so if not,
Yeah,
it'd be
no,
fun
I
to play
definitely
with.
want to do that.
Yeah.
It's on my list of ideas. I just need like all the grad students.
Yeah.
Working on my ideas. Did you have a question?
Yeah, it's similar to looking at different scales. You mentioned like New York had kind of a high vulnerability just due to its population. And obviously California covers a large geographic area. Is there a reason you chose to designate it by state instead of maybe smaller regions within the state? I can imagine that, population centers would be highly more vulnerable, or more agricultural areas would have a lot to shake out in California or New York, or those areas that have different values of that indicator that's not very homogeneous across the state.
Mhm. That's a good point. We actually didn't consider that, but that's a valid point. When you get all the data on a smaller level, that could make sense. Some of the indicators though, I'm thinking, for example, if I do recreational lakes here, if we're linking that to like incomes to the state, maybe if people come to say Lake Lanier and hang out there, it's not just impacting that little region, maybe there's more than one county, so it's a valid point to do a higher resolution. It might be a bit tricky to say exactly like this is just for this region, and whatever happens in there is not impacting the rest of the state, but good point. Yes.
I have a question actually. Like from previous example, we did know having catfish and then shrimp farming does cause imbalance in water resource, right? So why we didn't consider this in sensitivity, because here we have agriculture and cattle.
Mhm.
So why not just we consider the catfish and aquaculture?
Agriculture in there too, yeah, that's
Yeah.
that's a fair point, because we know in the southeast, that's an issue. Here we just have, it would be part of agriculture, percent of the area. But yeah, that, sure.
But it'd be included in agriculture as a, I mean, if it's listed
Yeah,
as a
yeah,
land use.
but it's
that's
small.
production, yeah.
Yeah, it's not. That's a good point. It should be percent of the area of the state that's designated agriculture, and agriculture would fall in there. But we're not considering specifically the fact that it's like in it most of water and makes it more valuable for that reason. But yeah, that's a fair point, you know, if it's a state that has activities that does it actively evaporates water. Yeah, for example, she put fountains in Las Vegas.
Yeah, right.
Yes.
I may have missed it in the talk, but, it seems like a lot of these impacts are affecting full watersheds rather than just states. Is there any examples of where maybe like a drought plan or an adaptive indicator is used across a watershed rather than just within a state?
I don't have any examples that I can tell you right away, but sometimes there are I think there are many cases, and maybe you know that better, but yeah, there are drought plans that are specifically for watersheds. Definitely for big rivers and so on. Definitely, we did not consider that here. But we did it more on a state level, considering like does the state have any plan if there's a drought hitting them? Because I realize some of them might be dominated by a big river. However, it's not just about the large river, it's also about all the smaller streams. And many of these states, they have no plan whatsoever. That's something that struck me when I came to Alabama. They're like, yeah, water levels are going down. Yep, that's happening. So we're sitting at the University of Alabama, and they're all, the Alabama Geologic Survey is there, and they're all just watching it. Nobody's doing anything because there is no plan in place. Maybe we should make a plan. Yeah, maybe we should. You know, so fair point. Some watersheds have it, and we did not consider that here. We just looked at the state level drought plans.
Yeah, it almost seems like a call to action to get states to start talking to each other rather than fighting over water resources.
Just what's in a state plan? An example, what kinds of things do they do to plan for?
Well, the things I have seen is more like the most obvious is like when water levels go down to a certain level, like what kind of activities do we adapt? You know, that's maybe the most obvious example. Like what do we do? Who should be informed about this? And what adaptive measures should be taken? Yeah, and that will be the extreme case, right? But already before that, maybe you should limit how much certain power plants can use, or how much certain places can pump for their irrigation, stuff like that. It's a bit more managed, and that decision makers are informed. Because right now, some states, you know.
So theoretically, Florida would have a very, very good drought plan.
Yeah, I would think so. You probably have better than me.
All the water management districts.
Yeah.
But going back all the way to the first study where you're looking at the change in the cumulative dry days. And so the frame was drought. And so the results were all about, okay, so we see in the future, there was blue on the maps, right? So there was this, the number of days of consecutive dryness, were basically droughts were getting less severe. And this in Florida. Yeah.
Yeah.
Oh, got a Florida focus, you know, that's okay. So of course, what, I mean, you know, the framing is drought, but so the, you know, the flip side is that it's wetter, right? I mean, so the interpretation that it's going to be less I mean, the other side of the coin is, you know, run CMIP 5 model scenarios for all of the downscale climate and look for changes in the extremes on the other side. So do you know much about that, or can you tell us what we are?
That's great.
I mean, I think people are doing it. I mean, from water management districts, you know, through all the way to the, you know, university folks, but
Yeah, definitely. Like now, obviously, we know that the dry period here during the cold season can be quite long, right? So maybe it's not too bad that it gets
shorter.
It's not as long. However, of course, it might affect the ecosystems are used to that long droughts. But yeah, as you say, at the other end of the scale, all the wet periods. That's a good point.
Yeah, I think we're quite, you know, we feel so certain about the range of temperature changes that are going to occur, but much less certain about the changing precipitation regime and
Yeah.
whether it's on the dry end of the
Mhm.
distribution or on the wet end. And so I think
Mhm.
there's a, yeah, and the score, the best models will be different, right? Because, you
Yeah,
know, predicting
probably.
extremes of dryness versus extreme events, you know,
Yeah, yeah.
maybe less good, I don't know, because big storms, big events are
Don't miss it all.
messing up, like
Don't miss
last
it
week.
all.
Yeah. We had a very quiet YouTube crew out there, which is par for the course. Any other questions from the room?
I have one quick question actually. In one of the slides, like, we discussed about when there's a drop in sea level water. So it's gonna eventually affect in Australia, right?
Oh, yeah,
So-
that one, yeah.
Yeah, that one's like really interesting actually, like.
It's not my paper.
It was wild when I heard about it, yeah.
But I read it as part of a class here with Dr. Davids. You haven't taken this class, do it. It's amazing. Oh, we read his paper and it was just, yeah.
Well, that was this study, okay.
What's that?
That was this study, this one, like.
No, you see, her name is, I don't know if I pronounce it right, Boning. So here are the references for that. And there's two papers from 2012 and 2013. So yeah, it was just the motivation that got me into this. And I think it's such a cool study. To start representing that.
Is this also based on the race of the life?
Yes, so it's one of the first studies using that. So they then measured that, where did the water go? So they looked at gravitational changes and found out that Australia got hit.
Right, it wasn't like a bunch of people moved there, right?
It's out there every decade.
Yeah.
So a lot of that water that evaporated from the ocean basically ended up here. Australia is so dry, works like a sponge when it rains here. So. And also quite a lot in the northern part of South America.
All right, let's give Dr. Engström another round of applause. Thanks so much. And for next week, everybody, we're gonna have our speaker for next week canceled, but that means Dr. Clark and I are gonna do a two-step. We're gonna do a dance up here about wetland policy in the US, which is changing like actually like minute by minute right now. So we're gonna try to capture that, talk a little bit about how the Clean Water Act recently was modified by a decision by the Supreme Court to allow groundwater to be considered, and then we're going to talk a little bit about a big case that's being heard by the Supreme Court